Today I'm going to show you how you can use the algeblocks to simplify some algebraic expressions. And when we were talking about the background knowledge that we have about algebra the other day, somebody brought up the fact that they know that simplify means you're not really changing the value, you're just making it a little bit more simple. And we are going to start with one that is very, very basic. Remember that algebraic expressions are the collection of variables and operations, but it doesn't have an equal sign. So this is the mat, the side of the paper that you're going to use to model today by simplifying some algebraic expressions. And we're going to start with a really basic one. We are going to start with making a model of 2y plus y. So hopefully we remember how that the y is the orange one. And there's a little bit of vocab that I want to go ahead and throw out to you guys. So you guys know that this is a variable, that the y's are a variable, but you probably don't know the name of the number in front of the variable. And that is called a coefficient. Actually, there should be another F in there. Whoops. Coefficient. And it's just the number that is in front of the variable. So that 2 is a coefficient, kind of like a coworker. You know, they're buddies. They go together. And actually, it's obvious that there's a 2 in front of the y, but there's actually a coefficient here, too, even though we don't have anything written. I wonder if anybody in the room has an idea of what that might be. It might be a good point here to pause the video for a moment and take a couple of suggestions. So I'm going to go ahead and continue. There's actually a 1 in front of that y. The same way that this means 2 times y, technically there's really, because this just means a 1 times y or 1y. Now, we don't write it there just because it's what we call, there's a word for when there's technically a 1 there and we just don't write it, and it's called understood. Like we all just kind of understand that there's technically a 1 in front of that y, but we don't write it there. So now let's go ahead and make our model. So 2y plus y. So I'm going to put 2 y's over here in the positive section of my mat. 2y plus y. So that means that I'm going to add another y. Well, what happens when you have 2y plus y? What does it end up being? What do you really have a model of there now? You don't just have, it's 2y plus y, but what if you wanted to make it just a tiny bit more simple? Take a moment, chat with the people around you, and pause the video. See if you have an idea if you were going to simplify 2y plus y, like make it as short and sweet as you possibly can. By looking at this model, it's going to take a couple of suggestions for what we think this might be equal to. Okay, I'm going to go ahead and continue. 2y plus y is actually a 3y. You've got y times 3. You've got 3 sets of y. So 2y plus another y is 3y. And this is as simple as it can get. So for simplifying this algebraic expression, making it as small and short and sweet as you can, 2y plus y equals 3y. Let's try another example. So 3x squared plus 2x squared. We're going to simplify it. So remember from previous days that this is an x squared. This represents x squared because it's got the dimensions of x long by x wide, so it's x squared. And because it's 3 times x squared, that means we need 3 groups of x squared. So we've got 3x squared. Now I'm going to add another 2x squared. So what is 3x squared plus 2x squared? What happens when I put them together? Pause this for a second, see if you guys can come to a decision, then restart the video and check your answer. Well, 3x squared plus 2x squared is simply going to leave you with 1, 2, 3, 4, 5 groups of x squared. So 3x squared plus 2x squared is 5x squared. Now that's all you can do. You can't simplify it anymore. We don't know what x is equal to, so we're just going to have to leave it here. A really common mistake that people make is that they think that when they simplify it, somehow they're supposed to put together, like, they get that it ends up being 5, but then they think they should combine these x squared into like an x to the 4th or something like that, but you don't do anything with those exponents. The variable and the exponents stay exactly the same. The only thing that changes is that basically you're just adding the coefficients together. Remember, the coefficient is the number in front of the variable. You're just adding them together. If you had 3 groups of x squared, then you had 2 more groups of x squared and added it all together. It gives you a total of 5 groups of x squared. Let's try one now that's a little bit more complicated. We've got 3x squared plus x plus y plus 2x squared. So let's start by putting the 3x squareds into our model. So these are x squareds. We need 3 of them because it's 3 times x squared. So 3 groups of x squared. Let me skip this up a little bit so I got some room here. Plus x, so we're adding an x, plus y, so we need to add a y, plus 2x squared. So now we need to go back in and add 2 more x squareds. So, once we've added all of that together, what do we have? We've still got our 1x, plus we still have a y, but then we have 1, 2, 3, 4, 5 x squareds. So we have 5x squareds plus 1y plus 1x. Now that is as simple as it can get if we're simplifying algebraic expressions. If you simplified this on paper, this is exactly what your final answer would look like. It can't get any shorter than this. Now, some people think, oh, but can't I do something about combining these x's together and make that into one big super thing? And the reason you can't is because, remember we were talking about instead of these being x's, let's say they're macaroni and cheese. Okay, and let's say I really, really like macaroni and cheese. So I'm going shopping and they're having a sale. So I'm on the, so we'll say that these x's are like just the right, let me get all this other stuff out of the way here. Make this a little bit bigger so we can just talk about this example for a moment. So instead of, so having a sale of jumbo boxes of mac and cheese. So I decide, all right, well, I'm going to go buy myself 5 jumbo boxes of mac and cheese. Then I realized that I probably need one to take to work tomorrow too. Well, I don't want to take the big jumbo box of mac and cheese to work with me because then I might eat it all because I have no self-control whatsoever when it comes to food. So I'm just going to buy myself a little small container of mac and cheese. Okay, say I give my sister a call later on and she says, hey, what'd you get at the store? I would say I bought 5 jumbo boxes of mac and cheese and I bought 1 regular box of mac and cheese. I wouldn't combine them all together and say, oh, I got 6 jumbo regular boxes. Okay, you don't combine that. They're really 2 different things. There's no way to really combine the 5 jumbo boxes plus the 1 regular box and just combine them into one big mass thing. They're related to each other, so they are not exactly the same thing. That is exactly how this situation with the x's and the x squareds works. They're very related to one another, but they're not exactly the same thing. There's a word, let's go back to our original example. Let me erase our answer for a moment. Going to learn a new vocab word that is called like terms. Okay, first of all, terms, just regular old terms, are these guys right here, the individual guys. So like 3x squared, he's a term. X is a term. Y is a term. 2x squared is a term. So they're separated in the expression by a plus or a minus sign. So they're the little groups, the little individual pieces of the expression. Those are what we call terms. Now, like terms are something a little bit different. Like terms have exactly the same variable or variables. So variable or variables, and those variables have to have the same exponent. So in the example we have above, of all these terms, the two that are like are 3x squared and 2x squared, because they both have x's, they both have an exponent of 2. X and x squared are not like terms. They've got the same variable part down, but they don't have the same exponent. So they are not exactly the same thing. When you're simplifying algebraic expressions, you're really doing what we call combining like terms. You'll hear this a lot. You're really combining like terms. You're finding the terms that are the same or that are like, and you're putting them together. So 3x squared plus 2x squared, we go back and we simplify this expression, gives us, as we found in our model a moment ago, 3x squared plus 2x squared gives us 5x squared. So then we still got the x plus the y. They're just kind of, you know, chilling out there, hanging out. But you can kind of put together all the x squareds into one mass term because they're like. Okay, here's another example. Hit the pause button on the video. Try to model this problem. 3y squared plus y plus x plus y squared. Try to model it and see if you can figure out, if you were writing it on paper, exactly what this would look like. Hopefully you guys have paused and you checked. I'm going to go ahead and work it now. So 3y squared. So that means I'm going to take 3 of my y squareds, and I'm going to put them on the positive side, plus y means I'm going to take 1y over to the positive side, plus x means I'm going to add an x right there, plus x means I'm going to add another x, plus y squared. So I'm going to add another y squared. So what do I have when I put everything together? I've got 1, 2, 3, 4 y squareds, plus I've got a y. Oops, I didn't want to write very well. There we go. Plus I've got 2 groups of x. Do you notice a little pattern here from where I started to what I got? Or what I ended up with, I guess I should say. So I had 3y squared plus y squared. Those were the 2 like terms. I combined them, put them together to make 4y squared. And you can tell, based on our model, that's what it looks like. Then I have just a plain old y. Now there are no other like terms in this expression to combine the y with. So he just moves straight down. He stays just the way he is. And I've still got just the plain y in my model. Then I have x plus x. Well, you put those two x's together and you end up with 2 sets of x. So 1x plus 1x actually just gives you 2 sets of x. So now let's try another one that's a little bit complicated. So 3x squared minus 4x minus 2x squared plus x. So let's decide how we're going to model it. So the 3x squared. Okay, so first of all I need to put 3x squareds and they're positive x squared, so they're just going to go right over here, minus 4x. Okay, so I need to take 4 x's for sure. And remember that when you're subtracting 4x, that's really the same thing as adding 4 negative x's. So we're going to add 4 x's, but we're going to put it over on the negative side. Minus 2x squared. Once again, they're going on the negative side because by subtracting 2x squared, we're really adding negatives. So minus 2x squared, then plus x. So now I'm going to add an x, but this one's a plus, so it goes over on the positive side. So refer back to our background knowledge and when we were doing positive and negative numbers. Now, if I were modeling, I'm just going to use this little space down here, and I'm going to pretend for just a moment that I am modeling, let's see, negative 3 plus 2. We'll just keep it nice and simple. So I would have 3 negatives over here, plus positive 2, and I would put 2 positives over here. And hopefully we remember that a positive and a negative kind of cancel each other out. So this positive and this negative, when they get together, they're going to be like, these don't go fun and poof like little chips do, but poof, they cancel each other out. So they're gone. Okay, then I've got another positive and a negative set here together. Put them together and poof, they're going to cancel each other out. So now they're gone. Well, that's going to leave me with a negative 1 left over. Well, it works exactly the same way with positive and negative variables, too. So I've got a positive x over here. I am going to combine it. I'm going to put it together with this negative x right here. So, poof, they disappear. They cancel each other out. So now they're gone. I've got a positive x squared. When I bring it together to combine it with this negative x squared, and I wish it would go poof, but poof, they disappear. Now I've got another positive x squared with a negative x squared. Put them together and poof, now they vanish. They vanish too. So what is left over from my model? Because now I don't have anything else that'll cancel each other out. Well, I've still got 1 positive x squared left and 3 negative x's. So it's x squared minus 3x because I've got a positive x squared minus 3x. Now let's look at what happened to that on paper. So I've got 3x squared minus 2x squared. Okay, they were the two like terms that I can combine. Think about it. So if you have 3x squareds and then you subtract 2 of them, well, that's going to leave you with 1x squared left over. Take a look at our other 2 like terms that we have. We have minus 4x. So think about this. So negative 4x's plus 1 positive x. Negative 4 plus a positive 1 is going to leave you with minus 3x. So what you're really doing is just kind of like the variable is staying the same, but you're adding the coefficients together. So negative 4 plus, remember there's technically a positive 1 here. We don't write it there, but it's technically there. So negative 4x plus positive 1x is a minus 3x. Now you could have done it, left it like this, or x squared plus negative 3x. These are actually exactly the same thing because doing minus 3x is the same as adding a negative 3x. So here's another example. Hit the pause button. You guys try to model this expression and try to use the models to simplify it. Then come back and restart the video and check your answer. I'm going to go ahead and go. So 2y squared. Okay, these are my y squareds. So I'm going to do 2y squareds plus y means that I'm going to add a plus y minus 3y squared. means that now I need to put 3 groups of y squared, but now they're on the negative side together, minus 3y. So I'm going to have 3 y's, but they are also on the negative side. So now let's see what I can combine to cancel each other out. So I've got a negative y squared plus this positive y squared. When they get together, poof, they cancel each other out. Now I've got another, well here, now let's do this x and this x just because they're close by. So when I put together this positive and this negative, poof, they cancel each other out. Whoops. Then I accidentally made that a little bit bigger. Okay, then I've got a positive and a negative y squared. Put them together and poof, they disappear. They cancel each other out. So what am I left with in my model? I'm left with a negative 2y squared minus y. So negative 2y squared minus y. So that's what the model looks like. Let's see how that worked out on paper. So my like terms that I could combine, I had a 2y squared minus 3y squared. Okay, so I had, oops, I goofed. I did something wrong there. What did I do? Somehow I've got an extra. I think I accidentally didn't move one of those out. Must be what I did. Okay, if I've got positive 2y squareds and then 3 negative y squareds, if I do, so this really should be negative y squared. Sorry guys, I think I left an extra one of those in there somehow. So positive 2y squared minus 3y squared. 2 and a negative 3 put together is a negative 1 y squared. Now technically there's not a 1 in front of, technically there's a 1 in front of that y. We just don't normally write it that way. So we're just going to leave it, and we're simplifying it. So we're making it as simple as we possibly can. So it's going to be a negative y squared. Then I had, I'll bet I know what I did. I'll bet I took out one of the y's instead of the y squared, because this is what should be in there right now. Sorry, guys. I didn't mean to mess you up. Okay. This is what our model should look like. I'll bet I accidentally took out one of these and took out a small one instead of taking out a big one. Okay, so now I've got do-over. Okay, so then my other like terms are positive y minus 3y. Well, this is technically a 1, so positive 1 and combine it with negative 3, that's going to give you a minus 2y. So you could have done it a couple different ways. You could have said negative y squared plus negative 2y, which is the same thing, or the order really doesn't matter. You just as easily could have said negative 2y minus y squared also. Doesn't matter what order you put them in, you get the same thing. Now don't be worried if you feel like this is still a little bit, this is very new to you, it's a little bit difficult. We're going to work on a handout, well, you guys are going to work on a handout in class using the versatiles so you can check your answer and just kind of try this out. Like I said, don't get too stressed out. Just try